Okay, this is 4.1 Introduction for Reactions. So our outcome is I can represent changes in matter using a chemical equation. So one way to represent a chemical equation is to use drawings to show what is happening at the molecular or atomic level. So in comparing these pictures here, we're going to start with hydrogen and bromine, and we're going to start to form some hydrogen bromide. So in pictures 3 and 4, we see that we are in progress of the reaction and we have a mixture of hydrogen bromine and hydrogen bromide. So in addition to identifying substances involved in chemical reactions, a chemical equation should indicate relative amounts of substances involved. So we know from the law of conservation of mass that the number of atoms has to be the same at the beginning and end of the reaction. So for number 2, we want to write a chemical reaction that is indicating the change that is occurring from pictures 1 to picture 2. So I have 2 of my hydrogen molecules and 2 of my bromine molecules reacting to make 4 hydrogen bromide molecules. In picture 2 to 3, we have the same thing happening, except only 1 hydrogen and 1 bromine molecule react to form 2 hydrogen bromide. So the number of hydrogen and bromine atoms on each side of the arrow are going to be equal. And because those atoms cannot be created nor destroyed in chemical reactions, the atoms that we start with are going to be the same atoms that we end with. So it is possible to create atoms through like nuclear processes, but those occur obviously in much different conditions than, our chemical reactions that we study in chemistry. Question 5, we want to describe how a diagram of a chemical process is different for a diagram of a physical process. So for chemical processes, we should be able to see that new products are formed from reactants. So those atoms are being rearranged. We also want to be able to tell bonds that are breaking or forming. We should see changes in our intramolecular forces. So those are the bonds that are holding together molecules or formula units or whatever. And they should also show that matter is conserved. So we should be able to count the number of each type of atom and see the same number on both sides. For physical processes, we should have the same chemical formula before and after. We're not making any new compounds here. We must also show any intermolecular forces. So these might be any new ones that form, such as whenever we dissolve a salt into water. And again, we still need to show that matter is conserved. If you have 10 grams of ice, you're going to end up with 10 grams of steam. So your reflection question is asking about how the dissolving of an ionic compound is often called a physical change, even though bonds are broken. So whenever we look at ionic bonds that are broken between sodium and chlorine, we form sodium ions and chloride ions in water. So the water molecules are going to surround the ions based on intermolecular forces. So that also provides support for this being a physical process. If you evaporate the water away, you're going to reform sodium chloride crystals. So all of that supports the idea that this is a physical process. But there are some processes where it's unclear whether they're chemical or physical, or maybe they have features of both.